Hello and welcome to this continued series on Unity Dots. Here I'm going to be showing in the next few videos a few different features that I've built on top of Unity Dots. These features are available in the repo that I'll show today, and they answer one way that you can solve particular solutions you'd probably need for gaming. My name is Asher Rivello. I am a Unity game dev with over a decade of experience in Unity, 25 years in game dev in total. I'm available for remote contract hire, doing Unity game dev stuff, including Dots, as well as educating around the game platforms. I've done game projects for PC, Steam, mobile, etc., and taught online and in person in various places. And I really enjoy learning Dots and sharing that with you. I've created a series of videos. This video here is a part of that, of course, and covering all sorts of different topics as I learn more about Dots and share it with the audience here. So a quick recap on Dots. I have earlier videos in the series. You can click up on the link there or follow the links in the description below to learn more about what is Unity Dots, why you would want to use Unity Dots, as well as what is the RMC Dots library that I've built on top of Dots. That's what we're going to be taking a look at today. It has a library of some core features itself, and then samples on top of those that I want to show off at least one of them today. So Unity Dots, as far as the concepts behind it, I want to pepper in a little bit of conceptual knowledge as I'm showing these. So the one to look at here in this video today is the singleton. So a singleton is any component, there's no special setup, but any component where you have exactly one instance in your world. Once you choose to do that, you can have some convenient ways to interact with it because you're counting on the fact that there's only one of them out there. Some of the APIs that are here, you can see they allow you to get read and write access in various different flavors from some different points in the API. If you think about it, a lot of the ways that we interact in Dots is with lists of entities or lists of components, because in a large complex project, that's probably what you've got. But if you choose to have exactly one of something, it just is a little bit simpler to get at. So we're going to see an example of that today that is both convenient and then also really practical for the use case. So we're going to look at a feature demo here. The different ones that are covered in the project, there's lots. So we've got animation, which takes a hybrid approach to using the traditional game object animator animation clip and bringing them in. Anytime I mention hybrid in this video or in the video series, it refers to using kind of the old paradigm, game object OOP, plus the new paradigm of Unity Dots. There's lots of reasons why we do hybrid. And in this particular case, it's because Dots does not have a native solution for animation yet. It's on the roadmap and it's coming. There's also an existing feature and a demo for the rest of what we see here, including audio clips, being able to play audio clips dependably from Dots, including things like pitch, volume, having delay when the sound starts, being able to easily destroy entities, for example, destroy after a few seconds. Having that built in is really nice. Being able to have your enemies follow your character around or having any object follow, having homing missiles follow your character or enemies through the follow feature. The game state feature is something that handles some of the really common use cases of game initialization, next round starting, when the game is over, being able to handle game pause and have all your systems know that they're being paused. Lots of different ways to solve that feature, but here's one that's really helpful for having that functionality out of the box. Input is about capturing your keyboard, mouse, and gamepad. Same old way you would do it with the Unity input system. This is built on top of that and translates it into a nice stream of data that you can use from Dots. I've got various physics examples and various spawning examples as well to be able to do things like trigger when two objects hit each other and be able to spawn new bullets, new enemies, new things like that, doing something like prefab instantiate from the game object world. If there's something you'd like to see from this list that I cover, then definitely leave me a comment below. And if there's features that you would like to see added that you don't see here, I'm looking for more features that I want to cover and make things that are easy and reusable across my demos, my prototypes, and I'm also sharing with the audience. The one we're going to take a look at today is capturing keyboard, mouse, and gamepad. I have a gamepad with us here today. And we're going to see how that works and being able to talk a little bit about the hybrid idea because we're taking advantage of a non-dots input system, which Unity has had around for years, and being able to bring that into dots and also taking a look at that concept of singleton. So here we are in the RMC Dots examples project, which has everything that we need to do dots. We could go ahead and start creating our own game inside the assets folder here. It's a great place to begin your new projects, but we can also go into the package manager, click on dots, and choose from some of the samples that are there. The one we're going to look at is the library demos, which are these demos showcasing features of the RMC Dots library. So let's import that now. And we see here in the project window that we've got samples, RMC Dots, the version number that'll change over time. And then we've got lots of different library demos here. Now, some of the ones that I'd shown in the slides are here. You may even see that there's more when you open this project because I'm adding more as I go. But the one we're going to take a look at here is the input. So I'm going to take all the other ones and I'm going to delete them and leave just the input. Now, deleting that way is purely optional. It's just going to help us focus and have a little less clutter in our project window. So I'm going to expand out, and this, like the rest of the library demos, has at the very least a scene that you open up. It may also have some additional assets and scripting. Some of these demos simply create an instance of whatever the system in the RMC library needs. And sometimes, just given the nature of the demo, you need to add a little bit more to it. This one's pretty lean as far as the demo doesn't bring too much new to the table. So let's explore. Here we've got a common game object that's just got the lighting and the camera for a consistent look and feel. Then we open up and expand the subscene, which contains all of the dots related game objects in our scene. We've got some nice dividers here that show these are the shared systems, which come from the RMC library. Here's the systems specifically created for this demo. So this is kind of throwaway code that would represent what you need to do on your end when you integrate this into a game. And then instances are the objects in the scene that kind of kick something off. So we've got one here, which represents the player. I'm going to go ahead and just run the scene. Now I can use the WASD keys to move around. I can use the arrow keys to move around as well. I can hit the space bar, and just as a temporary demonstration of clicking that, I make the player get larger, and also the enter key. So that shows all that. Now, if I go ahead and take any Unity compatible gamepad, turn it on, now the joystick connected, and from that, I can use the left stick to move around. I can use the right stick to move around. I can use one button and another button. We call this south button, east button, left stick, right stick. So the demo chooses to use left stick and right stick to move around, but in your game, you could read one stick for look and one stick for move, as you'll see in the code. So let's take a look at how this is handled inside the system and then also the demo itself. So a little bit of understanding here is that when we're clicking around and trying to understand what's in the library and what's in the demo on top of the library, one way that I've chosen to distinguish that is where I show shared systems here. These are the systems, let me expand here. These are the systems, if you see in the inspector, that are in the RMC library themselves. So this is the input system, which you could bring into any demo, to any game, and it's just going to give you input functionality. It's going to read the left stick, the right stick, that south button, and that east button, and you can choose in a game-specific way how to actually consume those. So the library itself doesn't tell you this input means move. That is the things that you do inside the demo. So as we begin to look inside the project window here, these are the demo-specific classes. And we've got one called Player Move System Authoring, and we can see that here. Now, I've chosen a convention, which I don't see every Dots developer do, but I want to have an easy way to turn on and off systems. So for every system, I create a system authoring, which is a mono behavior that just gives us this checkbox, and we can click it on or off. You'll see that used consistently through all of my samples here, in the library demos, the complete games that I've built. If you choose not to do that, that's fine. Many people don't, but just know that by default, Unity has all systems on all the time. And I find sometimes that's a bit overwhelming when you're trying to understand exactly what one given scene is using. So that's why I turn them all off unless you click this checkbox. So when you run this scene, it's already checked for you and it's all running. And next thing, next to the authoring is the system itself. And this is what we're going to dig into and look at here. So here is our custom player move system in the demo. If you're integrating the RMC Dots library into your project and you want to move or use the input for something, you would replicate what we see here. You would copy and paste this particular file as a starting point. The rest of what we don't see in this file is done for you beforehand. So let's step through it. So this is AI system. And the first thing that we do on create is we declare which different components or tags does this system need in order to run its update. So we first check that the player move system is enabled. That's handled by that authoring component. So when that's available for us, we know that this is a system should be running. And then important, anytime you're using any of the input component, you need to check to make sure that input component exists there as a second factor. So assuming that that's all set up right, like the scene is, then we can move on to the update. And we know that this update's going to be called every single frame from the moment you hit play forever in your scene. And what we can do inside here is be able to consume the input and learn all the different ways we can put that into our scene. So first in number one here, we see an example of the singleton API. So remember I mentioned that if you have more than one component of a given type, then that's not compatible with the singleton API. But if you have exactly one, then which my input system does, then this is how you get at it. And it makes sense to have it logically as a singleton here anyway, because the stream of input from your gamepad, from your keyboard, that's going to be available to you in exactly one spot. You don't necessarily want two copies of what the left stick is doing, at least not for a single player game. And my input system is only designed to handle one person at this computer. If you were playing multiplayer, that's fine. But as far as, couch co-op or something would need to be solved separately. So this represents the input stream coming from one person, and it's a combination of the way that Unity typically handles its input is you can map multiple different devices to the same movement. So here in number two, let me move that up for us here. In number two, once I've got a reference to that input component, I can read in the movement, which is the gamepad's left stick, the look, which is the gamepad's right stick or the arrows. You can see the comments there. And then being able to check the action 1 or action 2 if they're pressed down. Now, this will tell you true while it's being pressed down forever. If you want to get a kind of this frame, I've got something called was pressed this frame. So you can know the difference between a single click and holding down, which is just like the way that Unity's basic input setup works. And I find generally in game development, these are the only things that you'd need to do a lot of great prototyping, from moving a character around, from looking around if you have some control over the camera, or a twin stick shooter. The right stick could help you aim yourself as well, and then having two different input buttons there. Now, a limitation on the way that this is set up, as I mentioned, it's really for one person per computer. So if you wanted to have a second player taking separate input, then I would say that's a place where you would copy and paste my complete solution and then heavily update it for your needs. These systems are not meant to be so flexible. They're meant to be more for covering core use cases and being great for learning. So that's appropriate here. Also, if you needed, let's say, a third action button, like if you wanted to have the shoulder buttons or the triggers or something, trigger some input into your game, you would also want to just copy and paste this complete solution. Where flexibility does come in is number 3 here as I move up, really deciding now how do those left stick, right stick, and 2 action buttons, how do they map to my specific game needs? And that's what we've done here. So here in this section, I've got some custom move speeds. I'm deciding that, let's say, in this section, I want to be able to take either the left stick or the right stick. So what I do is I say, if you're currently moving the left around at all, then left is the stick that drives the input. The moment left stick is not being used, it then looks at the look, so the right stick. It's just an easy way to basically handle both left and right stick. You could handle that in some different ways too, if you wanted. Similarly here, I'm saying if either the input action 1 or the input action 2 is pressed down, either one of those will scale up the player. I'll run the demo one more time so you can reflect on left, right stick and the two different inputs. And then there's two different things that I'm choosing to do here. Now, these consequences aren't necessarily unique to my input system. They're just ways that you could choose to use the input. So you have a lot of flexibility here. So the first thing is about moving the character around. So what we do there is we look through the entire scene. We do a query on anything in the scene that has a local transform, which is basically everything that comes from the idea of kind of a game object and represents something in 3D space. It's going to give you potentially lots of items. Our scene is quite simple. And then I use the with all to make sure I'm getting only the player tag. So that yellow box in our scene has the player tag, and it's the only thing in the scene that has the player tag. So this for each loop, every frame is going to loop through and grab that one instance. Then what it does here is it's just going to update the position, and it's going to use our move. So I always factor in using delta time, which is just a good general Unity best practice. And that helps give you some smooth animation. So the second thing that we do here is we scale up the player. And I was just thinking of something that I could do that represents a nice visual effect of clicking a button. So here I again loop through, grab anything in the scene that has the local transform and the player tag. And I here am going to affect the scale. Now, I could have combined this for each with the for each above. I just wanted them to be quite separate in case you're playing with a demo and you want to delete the scaling portion. It's quite easy to do that here. And here I'm doing a lerp as well so that we get a nice slow, gradual increase in size or decrease in size. So we'll run that again and take a look. And one other thing that I'll do here is I'll duplicate the player so we can see how easily this system flexes with that. Notice that we're using for eaches, which is a very standard way to approach dots. For eaches are always going to capture as many items as possible, so it allows you to operate on systems. Now, when we think of the player, at least in a traditional game sense, we think of having one player controlled by one human. So there's not necessarily this idea of having multiple. But when you'd imagine commanding around a group of enemies and being able to scale and move them based on some other logic, you could think about having multiple enemies there. So here we are running the scene again. I'm going to use my arrow keys. I'm using the WASD keys, the WASD. I'm using spacebar here. I'm using enter here. And then what happens if I duplicate the player here? So I've got one player that's on the left, one player that's, let's say, a little bit higher than the other ones, and one player that's over here. I'll even rotate that one a little bit. And then we'll run the scene again, full screen. Now, notice that without doing anything to my system, I didn't even really conceive of it scaling up to having multiple players in the scene. But just by the nature of how Dots works, it's now looking into the scene, looking everything for that has that local transform, that also has a player tag. That's true of all three of these. And being able to move them around, and then also being able to change their scale and change their scale here as well. So just a little example there about how these systems scale up, they can apply to a small data set or they can apply to a large data set. So we take a look at how these systems are set up. We looked at how the input system demo works. If you want to look at the source code for the demo itself, let me just point to where that would be. So down here in the packages, which we have not looked at yet, there's RMC dots, there's scripts, and then there's a systems folder that has the source code for capturing the input from the Unity traditional Unity input system, translating that into that input component every single frame. And I invite you to take a look there if you want to see deeper inside of it. If you just want to play around with input in a Dots demo, then what we've taken a look at here is enough for you to get started and to be able to manipulate that script and play around. So that's it. That's all we're going to take a look at today. We've gotten the idea that there's different features available in the RMC Dots library, that many of those features also have a demo that you can include in your projects and use that as a starting point for inspiration. Or if you just want to learn about how these different systems work, from the input system we took a look at today to being able to move around and scale an object as well, you can see that there. So thanks for checking out this video. Check out the rest of the ones in the series. I'm going to put some thumbnails up here you can take a look at, and I am available for remote contract hire as a Unity game dev, as well as an instructor. Thanks.